Okay. Nakikita na? Nakikita yung screen
Opo.
and record na sa inyo. Okay, so I guess we could start, no? All right. So for today, again, we're going to discuss the structural framing system in towers and other vertical structures. Okay, so in most common buildings, bridges, and other civil engineering facilities or structures, there are two or more of the basic structural types that are assembled together to form a structural system that can transmit the applied loads to the ground through the foundation. Okay. So such structural systems are also referred to as framing systems or frameworks. And a component of such an assemblage are called structural members. Okay, so before we go on to the specifics, no, or the most technical systems focusing on towers and other vertical structures other than buildings, no, we're going to go on the basics of the structural framing system. Okay, so there is a classification of structures, no? But we're going to classify these structures based on the primary stress that may develop in their member or under major design loads. Okay, so this classification of structures is based or according to Aslang Kasimali from Structural Analysis 5th edition. Okay, so the first classification will be tension structures. Okay? So pag sinabi natin tension structures, these are structures that are composed of flexible steel cables, no, or frequently employed to support bridges and long span roofs. Okay? So because of their flexibility, cables have negligible bending stiffness. Okay? And can develop only tension. Thus, under external loads, a cable adopts a shape that enables it to support the load by tensile forces alone. Okay. In other words, the shape of a cable changes as the loads acting on it change. Okay. So usually, ang pinaka-basic form of tension structures is a cable. Okay. But it doesn't focus on the cables alone. No. There are also other other structural members that are applied purely with tension structures. Okay, so aside or besides cable structures, no, other example of tension structures will be vertical rods na ginagamit sa mga hangars. So for example, uh, to support balconies or mga tangke, no, and other membrane structures such as tents and roofs of large span domes. So makikita nyo sa mga, for example, sa mga arena or sa mga coliseum, there is this thing called vertical rod, no, to support long span, let's say is long span rafters, no. So to give more support do sa long span niya, aside dun sa the rafter supports itself to. Kasi when you're going to design a long span, it requires, of course, habang tumahaba, it requires a longer uh, or a larger cross section for that. No? So to reduce that, a tension rod is used or vertical rods are used to add as a support dun sa mga long span rafters na to. Okay? So the first one is the tension structures, no? Next. Next, we have the compression structures. Okay, so the tension and structures are both structures that develops mainly compressive stresses. Okay, so of course, ang difference lang sa isa, of course, for tension, and the second one is for compression. Okay, now if the tension structures have cables, no, the compression structures have arches. Okay, so pinaka-common na form of compression structures is the arch. Okay, so kung yung cable niya, ang cable is develops or shows a development of tension, no, dun sa member or structural member, no, opposite naman nun yung arch. So kung ano yung behavior ng cable when it experience tension, no, yung opposite niya will be dun sa arches. No? But other than arch, no, isa sa mga pinaka-common din na example of a compression structure is of course columns. Okay? So columns are straight members that are subjected to actually compressive loads. No? So the columns may also experience bending, no, or it may be combined with bending and axial. But the columns are pri- primary behaving as a compression structure. So mas ano siya sa axial. Okay? Next. We have here, the next one will be trusses. No? So very familiar tayo sa itsura or sa configuration ng trusses. So the trusses are composed of straight members connected at their ends by hinge connections to form a stable configuration. Okay. Now, when the loads are applied, now you have here the example like a P1, P2, P3, and P4. No? Now, when the loads are applied to a truss, only at the joints, its members either elongate or shorten. So, pwede rin siya nakaka-experience ng tension and compression. But, yun lang. Okay? Actual lang yun na-experience ni truss. Okay? Thus, the members of an ideal truss are always either in uniform tension or in uniform compression. Okay? Now, real trusses are usually constructed, no, by connecting members to gusset plates by bolted or welded connections. Now, although the rigid joints, no, does form cause some bending in the members of a truss when it's loaded, most cases, such as secondary bending stresses, are very small. Okay? And sa assumption ng mga hinge joints, it yields satisfactory designs. Okay? Now, trusses, because of their lightweights and of course high strength, kasi usually naman ang ginagamit are steel, no? These are among the most commonly used types of structures. Okay? Such structures are used in a variety of application, ranging from supporting roofs of buildings to serve as a support structure sa mga space stations and sports arenas or sa mga warehouses or hangars. No? You could also see structures na although it's a moment frame, no, may column and may beams. Usually yung ang ang form niya is in truss. So, may mga tayong tinatawag na truss beam, no? It serve as a parang brace din, but parang mukha siyang beam, pero ang configuration niya is truss. So, usually, ang tawag doon is truss beam. So, kasi it doesn't, kung meron man siyang bending, it has bending almost negligible, no? But it mostly behave as an actual structure which experience either tension or compression. Okay. Next, the fourth classification of structures are shear structures. No, so the shear structures are or such as RC shear walls. No, these are used in multi-story buildings to reduce lateral movements maybe because of the wind or maybe because of the earthquake excitations. No? So shear structures develop mainly in plane shear with relatively small bending stresses under the action of external loads. So isa sa mga um, pinaka-common form of shear structures is of course shear walls. No? So makikita nyo, these are um, greatly used, especially to tall buildings, because tall buildings is much more situated to larger lateral loads like winds and earthquakes. So habang tumataas yung building mo, bas nagre-react, mas malakas yung reaction ng building due to wind and earthquake. No? So to resist those large lateral loads, no, these tall buildings add shear walls to their buildings. No? So usually it may be a form of walls, no, or usually they use it as elevator shaft. No, it depends on the design. Okay, so there is a fifth. Sorry, there's also a. I haven't added that. No. Okay, sorry. The fifth classification according to Aslam Kasimali is the bending structure. Okay. So bending structures, of course, develop mainly bending or flexural stresses under the action of external loads. Okay, so in some structures, the shear stresses associated with the changes in bending moments may also be significant and should be considered in their design. No, so the most common figure or most common structure or the most common bending structure is of course a beam. Okay, alam naman natin na beams are structures that greatly affected by flexure or by bending. So hindi siya, it may have actual loads, no, but it's almost negligible, no. And aside from flexure, it also experiences shear because of the connection, no. And some of the forms of bending structures are, of course, rigid frames or moment frame systems. No, you also have slabs. This is also a flexural member. It acts like a beam, although it has a longer span. So it may also be considered as a flexural member. So some of the other common use structures there is the again beams, rigid frames, slabs, and plates. No? So unlike sa truss, which are subjected only to joint loads, no, the external loads to frames may be applied on the members as well as the joints. Di ba pag sa truss, ang pag naglo-load tayo, directly lang sa loads because ang trusses kasi wala naman talagang bending. So hindi, ang loads natin sa trusses is nasa joints lang for it to experience actual load, either tension or compression. Sa bending, you can apply this external load dun sa frame or sa beam within the member, no? Okay. So aside from these five classification of structures according to Aslam Kasimali, I added another one, no, which is the surface structure, no. So according to Hibbeler, aside dun sa tatlo, sa apat, there is, ano ba yun? Sorry. Aside dun sa apat, yung pang-anim is the surface structure. No? Pag sinabi natin surface structure, this is a this is a structure made by material having a very small thickness. No? Sobrang liit yung thickness niya, but the other dimensions are very large comparing to the thickness. No? So sometimes this material is very flexible, no, and can take the form of a tent or an air inflated structure. Okay, so in both cases, the materials act as a membrane that is subjected to pure tension. Okay, now surface structures may also be made of rigid materials. No, so aside from, let's say, a thin steel plate, no, this could also be in the form of a reinforced concrete. Okay, as such, they may be shaped as folded plates, no, or cylinders or hyperbolic paraboloids, no, and are referred to as thin plates or shells. Okay? Parang parang they act kasi as a cable or arch, no? Since they support loads primarily in tension din or compression with very little bending. Okay, so in spite of this, the plate or shell structures are very generally difficult to analyze due to the three-dimensional geometry of their surface. That's why sa modern technology, no, whenever we analyze surface structure like thin plates or shell structures, no, we use finite element analysis on that. No? So to accommodate the complexity of the computation for the analysis of this kind of structure. Okay, so these are the basic classification of structures, no, but they are classified as, or they're classified based on the primary stress that they develop in this kind of structures in their members. Okay, now because some of the structures are situated or susceptible mainly, or govern usually yung loadings nila to lateral force, no. So there are framing system that is mainly used to resist lateral force. So that's why we call them lateral force resisting frame system. Okay. So before we, kasi I want to give you then why are we discussing this, no? So because we, before we go on um to the specific framing system ng towers and non-building structures, no, I also want to give you an idea, kasi I don't think na na-discuss din sa inyo yung um, some of the lateral force resisting frame system. No? I would just want to give you an idea about this, but I think some of you already heard about the terms. No, just want to discuss more on this. Okay. Now, the first main known lateral force resisting frame systems are shear walls. Okay, so pag sinabi natin shear wall, parang yung, this is the most common form of a shear structure, di ba? Sabi natin shear wall, a shear wall is a structural member that resists cracking through in-plane shear. Okay? So, such that ground movement enters the building and creates inertial force that moves the floor diaphragm. Okay? Pag sinabi natin diaphragm, these are members that transform the lateral loads to vertical loads. So, a great example of diaphragms are slabs. Okay. Now, shear, or it could be slab, or this could be floor walls, no. But when we say floor diaphragms, these are the slabs. Okay. Now, shear walls resist this kind of movements, and the forces are transmitted back to the diaphragm below or to the foundation. Okay. It is essentially acts as a vertical spanning beam, no, to resist lateral force. Okay. Shear walls typically span from the foundation to the top of a building. Okay. They also perform well sa areas kung saan merong seismic activity. That's why like for example, sa mga buildings sa Manila, when you look at the tall buildings there, of course, Manila is very near the West Valley Fault, no? So they experience a lot of strong earthquakes. No? So that's why tall buildings um, is added by shear walls. Okay? Usually, yung shear walls naman, ang pinaka-common niya is concrete. So, but there are also sa ibang sa ibang klase ng mga structures naman, according to its materials, meron din naman siyang in a form of masonry, no? Pwede rin called form steel or wood framing. Okay, so kung hindi rin halimbawa, for tall buildings, usually ang ginagamit na shear walls are RC, buhos, no? So sa mga hindi naman kataasan na building, they're also using shear walls, but sometimes they use masonry or CHB kung they're going to replace RC. But they are using load-bearing CHB because they use shear wall, shear wall yung tinatayo nila. That's why they need a material that could resist lateral loads kasi nga yun yung purpose niya. Okay? Now, the strength and stiffness of a building depends on the shape and position of the shear wall. Okay? So, yung common positioning nung ano niya includes the building's perimeter o pwede sa labas ng building, no? Or usually, yung iba, yung firewall nila, they serve as na rin, they serve na rin as shear walls na din kasi buhos na rin pinapagamit nila eh. Aside from that, pwede rin sa gitna ng building. This could be an elevator shaft. Kung mapapansin nyo, may mga elevators na nasa gitna. Tapos, ang nakapaligid niya sa kanya is those stairs. No? So, yung shaft na yun, usually, buhos na rin yun. So, this also serve as a shear wall na din. Okay? So, merong iba-ibang forms ng shear walls. You have the rectangular, meron kang L-shape, C-shape, and the shear core. Yung shear core, yung may mga openings, no? Yung mga openings, yung shear walls na may openings, these are called coupled shear walls. Okay? Next. Another lateral force resisting frame system is the moment frame. So this is the very common and very traditional framing system. Okay, so the moment frame system composed of vertical frames with traditional beams and columns. Usually, pag steel, they are connected by bolts or welds. And kung concrete naman, there are monolithic. So, monolithic yung buhos pag sa mga moment frame. So, they could have rigid connection, no? Now, the rigid connections, connection points, no, they permit the frame to resist lateral loads through the flexural strength or the bending strength and the continuity of its beams and columns. Okay, so such that moments are transformed from the beams to columns at the connection. Okay, at the connection points. A moment frame will not move laterally without bending the beams or the columns. Okay? The three main types of connections, no, they could, again, pag sa steel, they could be bolted, welded, no, and the, again, pag concrete, it should be monolithic. Pag sinabing monolithic, ibig sabihin sabay yung buhos. Kailangan sabay yung buhos ni beam and column for it to have, again, a rigid connection. Okay? So, pinaka-common na frame pagdating sa mga buildings, especially sa Philippines, no, pinaka-common na framing system na ginagamit sa Philippines is the moment resisting frame. Okay? So, meron tayong tinatawag na tatlong types of moment frames. Meron tayong OMF, that is the ordinary moment frame. You have the intermediate moment frame, IMF, and the SMF, the special moment frame. So, pinagkaiba lang nilang tatlo is it depends on the location of your building, no? So, if your building is situated with no or low seismic activity, you could use ordinary moment frames. No, pag low to mid naman, yung seismic activity sa area, you could use the intermediate moment frame. And kung mid to high, yung seismic activity niya, no, you could use the SMF or the seismic moment frame, a special moment frame. So, pinaka actual difference niya is on the detailing. No? So, I think i-discuss na yan sa inyo pagdating sa advanced concrete. Di ba nag-advanced concrete na kayo this sem, no? I think, or I hope the detailing on the concrete, especially for special moment frame systems, sana ma-discuss sa inyo kasi it's very important, no? But anyway, another one is a brace frame. Okay? So, pag brace frame, yung brace frame, pinaka-common siya sa steel construction kasi mas okay siyang gamitin in terms, or mas madali siyang tayo in terms of its connection. Okay? They could be in diagonal or in triangulated steel beams or cables. Ang pinaka-purpose niya, of course, is to resist lateral force. So, with the use of brace system, it could help in resisting larger lateral forces. Okay. Now, resistance is provided by of course, vertical bracing and horizontal bracing. Okay. Pag sinabi natin vertical bracing, these are the bracing between structural columns. No, transfers the lateral forces to ground level. Okay? Pag horizontal bracing naman, each floor or the roof transfers lateral forces to the vertical bracings. Okay? So mapapansin nyo, these are the most common types of brace frames in commercial buildings. Okay? Now, however, the floor system is usually a sufficient diaphragm without the need for additional steel bracing. Okay? Brace frames are situated for multi-story buildings in low to mid-rise range. Okay, so pinaka-main type ng brace frame are concentric bracing and eccentric bracing. Pag sinabi natin concentric, naka-triangulated, it forms a triangle. Parang truss din yung behavior din kasi niya eh. It develops joints, no, which acts like a truss. Kasi pag we can only say na the structure is a truss pag when they are forming a triangulated connection or triangulated form of the members. No. So, pinaka-common niya is cross brace. No, you also have here inverted V brace and single diagonal brace. Now, the other one naman is eccentrically bracing, no? So, this utilize diagonal braces with one or two ends, no? Deliberately offset to the supporting members. So, yung offset niya is what we call the structural fuse region. Now, the gap between the offset bracing is again referred to structural fuse region, and it's designed to dissipate a lot of energy during earthquake event. Okay? Now, so let's go on to the types of towers though. So these towers, no, they are most commonly used to telecommunication towers, to meteorological towers and other sorts of towers for different purposes though. But these are the types of towers based on its structural actions. Okay. So you have here self-supporting tower or lattice towers. You have guide towers or mast or monopole. Okay? Now, pinakauna natin or pinaka-common, ito nakikita nyo na to kahit saan kayo pumunta, is the self-supporting tower. Okay? So, the self-supporting tower is also called a freestanding towers or lattice towers. Okay? So, generally, ang cross-section niya is a square. No? Pag square, it has four legs. No? It could also be in ang cross-section niya could also be a triangle with has which has three legs. Okay? And these towers acts like a cantilever trusses. No? And these are subjected mainly with wind and seismic loads. Okay? Now, freestanding towers are commonly used sa mga TV, sa mga microwave transmissions, power transmissions, floodlight holding, and etc. Okay, so mapapansin nyo, so usually, these are used kapag medyo matataas yung towers. Okay, for a while. Okay. Like for example, di ba, gaya na lang sa mga um, television stations, no? Like, makikita nyo dyan sa ABS, di ba? Ang tower nila dyan is a self-supporting tower o lattice towers. Sa ba? Usually, yung mga tinatayo ngayon, di ba? Yung mga new constructed towers na tinatayo ng dito and other telecommunication companies, no? Ito yung pinaka-common na ginagamit. So, they usually use this kapag they have a great amount of available area, no? So, kung mapapansin nyo sa Manila, hindi ito ang ginagamit. Kasi nga, wala masyadong area na uh, available doon, no? So, kasi if you're going to use a self-supporting tower, you need, of course, you need to have a large area. Kasi habang tumataas, lumalaki din yung magiging base area niya. Okay? Now, you have different kinds or you have some common configurations, no, with bracing systems. Okay, for a while lang. Medyo naghahang lang yung PowerPoint. For a while lang, restart ko lang yung ko. Okay, nakikita na ba? Ulit?
Yes
Hello?
po.
Okay, so we can continue. No. So on lattice towers or self-supporting towers, there are some common configurations with bracing systems. Okay, so again, these lattice towers acts like a truss, though, but it acts like a cantilever truss. Kasi when we say cantilever truss, the members acts like a trust members, and it is supported by maybe a mat foundation or isolated footing in which yung connections niya is a fix. So that's why sabi natin, it acts like a cantilever truss. Okay, so these are some common configurations, no. The first one is a single diagonal bracing. Okay, pag sinabi nating single diagonal, the letter A, no? So you have there the simplest form of bracing. So you only have um, the panel and a single diagonal member. Okay. Now the wind shear at any level is shared by the single diagonal of the panel. So such bracing is used for towers up to 30 meters height. Okay. Pag mas maliliit yung towers, no, um, yung configuration niya na madalas ginagamit is this single diagonal bracings. The next one is the XX bracing or the diagonal bracing. So, ang pinagkaiba lang niya, to sa isa, of course, may additional na main diagonal. Okay? Pero, this one has no horizontal bracing. So, mas ginagamit siya sa mga towers na mas mataas, up to 50 height, 50 meters height. So, this one and the first one is considered to be a statically determinate structure. Okay, so this could be computed using the basic equations. No? The next one is the XB bracing. Okay. Pag sinabi natin XB bracing, meron kang double diagonal with horizontal bracings. Okay. So, such bracings are quite rigid. So pwede siyang gamitin up to 50 meters height. But comparing to the second one, to the double diagonal, this XB bracing is statically indeterminate. Okay. So, the horizontal members and redundant members are carry can carry only nominal stresses. Okay. The fourth one is the K bracing. No, this fourth one, no, the figure D. No, such bracings gives a large headroom. Okay. Again, this structure is statically determinate, like the first two. No, and this could be used for 50 meters up to 200 meters in height. Okay. Sa fifth naman, you have the XBX bracing. Now, this is a combination of XX and the XB. No? So, meron kang double diagonal na may XB. So, meron kang horizontal and double diagonal. Although, compared dito sa XB, kumbaga, iba yung configuration, no, ng kanyang diagonals, no, na it has also crossing of diagonals. Okay? So itong figure na to is, or this configuration is a statically determinate structure. So pwede din siya to 50 up to 200 meters in height. Okay, the next one is a W bracing. Okay? The systems uses a number of overlapping diagonals, no? So compared to the first five, so first five except to the fourth one, no, mas marami yung overlapping ng structures nung diagonal members niya. Again, this is also statically indeterminate. Okay, but however, the effective length of the diagonals is reduced. Okay, so the system is quite rigid also, and this could be used for 50 to 200 meters of height. So, hindi ako masyadong nakakakita ng mga ganito klase, no? Yung isa sa mga pobo talaga is yung the first five. Okay. The next one is the Y bracing. Okay. Yung Y bracing naman, this system also gives a larger headroom. Okay. And can be used for lower panels. Okay. These are also the system is also considered to be a statically determinate. Okay. The next one is an arch bracing, no? So this is adapted for wider panels. So it has also greater headroom, and the system is called to be a statically determinate. Okay. The next one is subdivided V bracing. Okay. So ito yung mas ginagamit sa mga matataas and sa mga mas ginagamit sa mga tall communication system towers, radio, and TV because they are carrying heavier um, heavier loads. No, aside from resisting lateral loads like wind and earthquake, they are also subjected to larger amount of gravity loads from the antennas. Kasi there are a lot of antennas like for example a microwave antenna. They ranges from smaller sizes with um, 500 millimeter in diameter up to 3 meters in diameter. Okay, so of course, with larger diameter, they are also heavier. So if they are placed to towers, no, ideal bracing for that is subdivided V bracing. No, kaya mas ginagamit siya sa communication towers and TV towers and also transmission towers. Okay, and lastly, you have the diamond lattice system. So the typical diamond lattice system used for towers up to 100 and 200 meters in height. Okay, so the base width is kept at a 1/5 to 1/6 of the height. Okay, so mas common siya sa mga mas matataas na towers. Okay, so this is an example of a lattice tower. So this is situated in Oriental Mindoro, if I'm not mistaken. Okay, so this is a tower of smart. Although hindi pa gano'n ka dami yung nakalagay sa kanya na microwave or panel antennas, no? But these are kumbaga built to prepare a larger amount of gravity loads due to these antennas. Okay, so I'm going to show you an example of a plan, no? Okay, so this is an example of plan by Smart. So this is situated in North Cotabato and Ross, North Cotabato, no? So this is a 48-meter lattice tower. Okay, so ang pinaka harap ng mga structural plans for towers to is already the tower elevation. Okay, so beside the tower elevation, no, nandiyan na rin yung table of the steel member use, no. So um, aside from this, of course, for the dimension, no, you also have here the labels for its sections. So kanina may nababanggit na tayong panel number, di ba? Ay panel. Pag sinabi nating panel, this is a group of members, no. So this could be or this could have um, uniform height of panels, no? So, pwede rin iba-iba yung height ng panel. Depende also, of course, to the design of the structural engineer. So, depende kasi sa bracing configuration niya, but commonly, part of the panel is from one horizontal bracing to another horizontal member. Okay? So, dito, so meron ka tinatawag na SP1, SP2, SP3, SP4, SP5, SP6, SP7, SP8. Ang pinaka-8, ang 8 kasi is nasa pinakamababa. Okay? So, I haven't mentioned kanina, usually, design for bracing configurations, no, it's not strictly to one bracing system or one bracing configuration. Usually, it is a combination, no? So, pwedeng pagdating sa taas, kunwari, pwedeng single diagonal ka na lang from the first fifteen meters, no? Tapos pagdating sa baba, pwedeng iba na. Pwede ring ginamitan na siya ng subdivided V-bracing or X-V-bracing. Depende. Of course, depende din sa design. No? So dito, rotate ko lang para di kayo nalilito. We have here the first dito sa table, you have the different panel number from 1 to 8. So, naka-group siya from 1, 2, 3, 4, 5, 6, 7, and 8. So, meron kang tinatawag din, meron tayong tinatawag 3 members. No? So, there are leg, the main diagonal, and the horizontal member. So, yung leg, of course, ito yun. Okay? Itong nasa gilid. Hindi ko lang ma-highlight. Ay, pwede ata i-highlight eh. So, this one, ay, pa siya na-highlight, no? But anyway, nakikita ba yung ano, yung cursor ko sa ano? Mouse? Hindi no. Okay, anyway. So yung leg na tinatawag natin is this one, no? Ito yung main kumbaga parang this serve as a column, kumbaga sa building, this is the column. This is the main member. Siya yung nagdi-distribute tong load from the bracings up to the siya yung nagdi-deliver ng load to the foundation, no. So meron din tayong tinatawag na main diagonal. Of course, yung diagonal members, no. So these are what we call the main diagonal. And there are also main horizontal, no. Comparing or looking at this plan or this tower elevation, as you can see, isa lang yung nakasulat na main horizontal sa panel number 1 lang. Ito yun. Ito yung nasa pinakatuktok, nasa elevation 48 meters. Okay? So looking at the table, wala siyang nakasulat na other steel section sa other panels because wala naman tayong horizontal members. No? Okay? So sa other design, or sa other towers, meron kayong makikita sa other plans na meron siyang tinatawag na secondary diagonal or secondary horizontal, no? So babalik ko lang doon sa presentation. So makikita nyo dito, ewan ko lang kung you can clearly see, no? So para siyang combination or para siyang subdivided V bracing, no? So pagdating sa taas, I think it's ilang panels ba? Hindi ko siya nakikita. Parang nasa 4 na panel. So let's say this is the first 12 meters, no? So straight lang yung or uniform yung width niya. Okay? So ibig sabihin hindi nagtitaper yung cross section niya. No? But within the elevation of the towers, pagdating dito sa, hindi naman siya gitna but within the first half of the tower, nag-start na siya to taper. No? So usually, ganito yung mga designs ng different towers. No? So this is a combination of subdivided B-bracing and sa taas, XB bracing, no? So sabi natin doon sa table or sa plan kanina, may nakasulat doon na main diagonal and main horizontal. So dito, itong maliliit na to, this serve as a secondary horizontal, no? And this yung mas maliit na diagonal member, this is called the secondary diagonal. Okay, so very iba-iba. Kumbaga maraming klase ng configuration when it comes to lattice towers or self-supported towers. Okay? So the next type of tower according to or based on the uh, structural action is the guide towers or guide mass. Okay? Now, guide towers are normally guide and 3 directions, no? Or depende. Depende rin sa action or sa requirement niya. But basically, the guide towers are hinged to the base and supported by what we call the guide wires. Ito mga parang tension rods na nakikita nyo na situated or attached to different levels of the towers. So these are what we call guide wires or guy wires. So kaya siya tinawag na guide towers or mast. Okay? Now due to this reason, guide or of course, this transmit wind forces to the ground. Okay, so because of this reason, the kite tower of the same height is much lighter than a self-supporting tower. However, it requires much larger space in plan, according to the in plan to accommodate the placement of guy ropes. Okay, so ang difference naman nito, although comparing to the self-supporting lattice towers to sea guide towers, it requires larger area kasi habang tumataas, no, tumataas yung height or elevation ng guide tower or mast mo, it requires a larger area because kailangan mo na mas malayong placement nung um, tension mo. Kasi kung mataas man yon tapos very steep yung slope nung um, very steep yung sloping nung magiging guide wires mo, hindi siya kumbaga mas matibay kasi when you place your guide wires to a farther distance from the base of the tower, no, so kumbaga mas maliit lang yung angle of the guide wires. Okay, so ang ang pros naman niya comparing to a lattice towers, of course, mas magaan siya kasi hindi naman siya nagre-require ng maraming materyales, hindi siya nagre-require ng maraming steel members, no? So, mas magaan siya kay lattice tower at mas mura. Mas mura yung magagastos. Although, kumbaga, makakabawi ka lang dun sa, babawiin lang niya sa land area na kinakailangan niya. Okay? So, pag sinabi nating mass, it is like a column, no? But it is in the form of truss. It is situated with truss members, no? Like this one on the picture, no? So, this is a guide mass. Pag sinabi natin guide mass, usually ang cross section could be a triangular or square, no, pero pinaka common na cross section ng mass is triangle, no. So pag towers naman, usually it could pag sinabi natin guide towers, this could be a a single member or pwedeng kumbaga like for example a tubular tower lang siya, no, with guide wires. This could also called to be a guide tower. Okay. So any tower that is supported by guide wires is what we call a guide tower or guide mast. Okay. So the common parts of guide mast are, of course, the foundation, no? So, meron kang steel mast. Ito yung mast or yung tower, pinaka main tower niya, no? This could be a pole or a mast. And it is assumed to be a pin connected. So it generally has a pin foot. Okay. Now, you also have guide cables. Okay. The main component. Kaya nga siya tawag na guide mast o guide towers because of the guide cables. Okay. So aside from the guide cables, you also have structural accessories like the connection, no, or bolted connections, or you also have different appurtenances, and of course the equipment or the antenna, yung pinaka gravity load aside this self weight ng ating towers. Okay, so this is an example of a structural detail for steel mast, no. Makikita nyo, again, sabi ko nga kanina, isa sa mga common cross section niya is a triangle, di ba? So you have here the cross section of your mass, no. So this is the horizontal main horizontal member of the mass, no. And looking at the elevations, no, this has also main diagonal. That's why it also act like a truss, no? So for this sample of guide tower, you have guide cables or guide wires situated in different or various levels of the tower. So meron kang, like for this, you have guide wires connected every 6 meters of the tower. Okay, so you have the total elevation of the tower to 200 centimeter, no? Or this is 20 meters. No? So for every 6 meters, meron siyang nakakonect na guide wires. And yung guide wires natin is placed in 3 directions, no? So meron kang dito sa harap, meron sa gilid, meron ka rin sa likod. Okay? So for the connection, usually kapag ang isa sa mga common naman is bolts or weld, or it could be a combination of bolts and weld connections. Okay? So if you have, aside from 3 direction of guide bus, meron ding iba na with 4 faces or 4 directions of guide wires. So parang naka-eke siya. So meron kang um, for northwest, northeast, southwest, and southeast. Okay? So depende sa design. Usually depends on the direction, governing direction of the wind, no? So again, katulad dito sa isang figure, the second tower is connected with guide wires for every 6 meters then. Okay? So these are the typical details, no? So you have here the cable. And this is the gasket plate. Usually ganito yung connection ng ating guide wires, no? So meron kang concrete block na it also have a self, or meron siya sa foundation, no? Para rigid yung connection niya to the ground. And these guide wires are pre-stressed with kumbaga loaded with pre-tension. That's why when you design guide wires, dapat alam mo yun yung pre-tension force na gagamitin when constructing a guide wires. Okay? So for different configurations, no, there are also a lot of different configurations na according to the structure. Okay? So meron kang solid structure, you have truss structure and variable section. Pag solid structure, again, yung gaya na sinasabi ko kanina, yung tubes or tubular section. So these are the guide towers na sinasabi natin. So this could be, or this is commonly connected with guide wires in 3 directions. No? So for every 120 degrees yung connection or yung distance ng mga guide wires natin. Okay? So this is an example. Ito, this one. So this is a solid structure made up of structural steel tubular section. Okay, so it has 1, 2, and 3. Okay. The next one is the truss structure, no? So these are the guide mast naman. Ito yung mga guide mast na sabi natin. And usually it has guide wires connected in 4 directions. No? So for every 90 degrees. Okay? So for every 90 degrees there is a guide wire connected to the mast. So example of this are these 4 figures, no? So ano bang marami na dito eh. Ako siguro nakikita rin yun. Yung tower sa tabi ng DPWH, yung mataas na yun. So that is an example of a truss structure or a guide mast. Yun yung makikita nyo, ang liit lang ng structure, pero sa taas niya, kailangan niya ng mas malaking area kasi kailangan mas malayo yung placement doon pagpapatungan or pagkokonektan ng guide wires natin. Okay. And again, there, aside from solid structure and truss structure, you also have variable sections. Pag sinabi natin variable section, nagva-vary or nagtitaper yung cross-section niya, comparing from the top of the tower up to the below or near the foundation of the tower. So makikita nyo, like for this example, sa pinakataas, sa pinaka-top or sa top of the tower, maliit lang yung cross-section niya, almost point na lang, no? And as you go down to the foundation of the tower, mas lumalaki yung cross-section niya. And pagdating sa gitna, up to the lower, no, lumiliit naman. Lumiliit naman yung cross-section ng tower niya. And ito din, the figure below. Pagdating sa taas, from the top, you have a square cross-section, no? But as it goes down, paliit ng paliit. Okay? So these are different configurations of guide mass or towers according to its structure. Okay? And lastly, you have the monopole. Pag sinabi nating monopole, it is a single self-supporting pole. So usually, ginagamit to sa mga roof deck, or high-rise building. Ito yung commonly na ginagamit ng mga telecommunication companies sa Metro Manila because of the lack of land area na pwedeng pagtayuan ng lattice towers. Ang ginagamit nila is monopoles, and they are placed above roof decks of mid to high-rise building. Okay? So usually, ang kalakaran kasi dyan, pag halimbawa ako may building ako, may commercial building ako, and si telecommunication company, si Smart or si Globe, they want to place a tower in this area para ma-enhance yung signal, no? So, pag ako yung may-ari ng building, they will rent the space, babayaran nila yung space na yun, to place their towers. So pag usually mga roof decks, ang nilalagay diyan is monopole. Okay? Pero ang common configuration niya is, ang usually ginagamit is three-legged or four-legged. So aside from its monopole or the self-support or single pole, there is also leg. Kung if the monopole is using steel tubular section, usually yung leg niya is also tubular but with smaller cross section of the steel pole. Okay, so usually for monopole, mas nagre-require siya ng lesser height, no? Mas ginagamit siya sa mga mababang tower comparing to guide mass and self-supporting towers. Okay? And also, kung hindi naman ganun kabigatan. But there is also instances na kapag matataas, minsan gumagamit din sila ng monopole towers. Okay? So, meron tayong tinatawag na vertical shaft. The vertical shaft is what we call the single pole. Yung pinaka-tower o pinaka-pole nung monopole natin, that's what we call the vertical shaft. Okay, sorry. This could be a continuous tapered or step pipe monopole. So it varies in different sizes and also configurations. Okay, so pag tapered, of course, as you go higher to the elevation of the tower, nag-differentiate or nagva-vary na yung cross section nung ating shaft or ating single pole. Okay? So, pwede ding steep yung pipe, no? Pag sinabi natin steep, nagre-reduce din yung size niya, although by panels or by like for example by 6 meters ganyan or by 9 meters. Usually it depends on the supplier din. Halimbawa magko-construct ako ng tower, tapos let's say I'm going to construct a 12-meter monopole situated in a roof deck. So, usually, di ba, pag bumibili ka lang bakal, ang usually base length lang niya is, pinaka-common is 6 meters, di ba? So, ang gagamitin ko from the foundation, from the support of the tower up to 6 meters, isang klase ng cross section. Tapos, of course, magsa-splice ka nung tubular mo. So, kung depende sa design, kung pwede na, o i-allow na nung, based on your calculation, pwede na gamit ng mas maliit na cross section, no. So for the remaining length, no, it could use different different size or smaller size of cross section for the steel pipe. Okay? Yan yung pinagkaiba ni tapered and ni steep, a step pipe. Okay? So isa din sa mga common towers, we also have what we call the transmission line towers. Okay? So pag sinabi natin transmission line towers, this supports extra high voltage of electric transmission lines. Okay? So dahil it carries heavy currents on these transmission lines, kailangan tong ilagay sa mas matataas na level compare dun sa ground. Kaya makikita nyo, for example, when you travel going south, no, mapapansin nyo yung mga transmission lines, no, matataas yung height ng towers na to. Or, aside from having a higher height of its own, the height of the tower alone, it is located or placed sa mga mas matataas na lugar. Like, for example, sa mga bundok, di ba? Because it carries extra high voltages. Okay? So, for transmission line towers, you also have different configuration with bracing system. Halos kamukha din niya yung mga nabanggit nating configurations kanina, no? And kagaya din niya yung nabanggit nating configuration, meron tayong double diagonals, no? You also have here, mapapansin niyo yung double diagonals, XB bracings, no? You also have, aside from self-supporting, meron ka ring lattice or naka-guide wire, no? So, very, very the same. Kumbaga, not very the same, but it uses almost the same configuration with other or the general lattice towers din. And it could be a combination of guide wires or guide towers and lattice towers. Okay? So for further classification, no, for the classifications of towers, you have first the basis of the standard shape of the parent material. Pag sinabi ng parent material, yung pinaka-shape nung bakal natin. Okay? So pag monopole, ang pinaka-ginagamit talaga niyan is circular shape or yung tinatawag natin na steel pipe. Okay? So dahil maliliit lang yung height ng ating monopoles, we could use one of the common steel section, which is the steel pipe, no? And of course, ang placement kasi, of course, ang paggagamitan ng monopoles is commonly used is for telecommunication, no? So ang placing of antennas is paikot. So mas okay na gagamitin mong steel section for your monopole is a circular shape. Okay? Now, for poles naman, other than the monopoles, you have di ba, nabanggit ko kanina, aside from a single pole, mayroon mga poles that uses legs or it may be a three-legged or four-legged poles, no? So usually, aside from that, pwede rin gumamit din ng tubular or hybrid. Pero mas common talaga dito sa atin, ang ginagamit is circular or circular shape or steel pipe. Okay. Sa lattice naman, or sa mass, it could be a tubular, a steel tubing gagamit, or angular, or hybrid. Okay, pag hybrid, pwedeng kung matataas na or if it requires a larger steel section, usually ginagamit na dyan is a WT section or a W section. Okay, so either of the three, we may have tubular, angular, and hybrid for both lattice and mast. Okay, so another classification is based on the legs of the tower. No? So pag monopole, no, of course, wala ka naman leg nun, single lang siya. So you don't have a classification for that. So pag post, it could be brace, unbrace. Ayan yung sinasabi ko kanina, two-legged or three-legged. Meron pa nga yung four-legged eh. Depende. Pag lattice and mass naman, you have three-legged or pag sinabi natin three-legged, triangular yung cross-section ng ating towers or yung ating when you look at the cross-section of every panel, no? Ang pinaka-common cross-section niya is triangle for three-legged lattice or mass towers. For four-legged naman, for all the panels, no, ang cross-section niya is of course square or a rectangle. Pero pag lattice and mass talaga, ang cross-section niya is square talaga. Well, usually equal or uniform yung distance from one leg to another. Hindi gumagamit ng rectangular. Laging square yung cross-section for four-legged towers. Okay? And last classification is based on the placement of structure. So you have ground-based, you have ground-based structure, which is has its own foundation, no? So kung lattice tower ka ang if it's ground based, so you have a mat foundation or isolated footing, depende sa design or actually depende din sa height. Pero pag habang pataas, of course it caters greater amount of lateral load, so it supports greater amount of load. So, kailangan niya ng mas malaking foundation. So, pag pataas na pataas, mat foundation yung ginagamit natin. At kung may guide mass ka, no, aside from the foundation of your mast or your tower, you also need support for your guide wires situated or located in different directions. Okay? So pag rooftop, you also have another classification based on the placement. You have the rooftop. Sabi ko nga, madalas ginagamit sa, ito yung madalas na ginagamit sa roof deck. Sa madalas ginagamit sa Manila. Okay? So, usually, it uses monopole or pole with three-legged or four-legged poles, no? Pole towers. And minsan may makakita ka rin pag matataas yung mga buildings, meron ka rin makikita ng mga guide mass or guide towers, no? So, pag mga guide naman na nakalagay sa rooftop, usually, bolted lang siya, naka-base plate lang siya. And pati rin yung supports nung guide wires mo, no? So, pwedeng direkta na siya sa columns or sa beams. Of course, when you're going to construct or build a tower on rooftop structure, it has to be made sure na yung tower is kayang pang i-carry ng existing building or existing structure. Okay? Kapag ang connection naman, ang connection usually kasi ng ating or ang support ng mga tower sa roof deck, minsan, kung mapapansin nyo, minsan naka-bolt na siya or naka-base plate na siya directly sa column or sa beam. Kung minsan kakayanin pa ng beam, minsan sinasakto i-base plate sa beam. So, or kung hindi naman kakayanin minsan, direkta na sa column. Especially kung bago pala itatayo yung tower, tapos matagal na yung building, no? So if the location of the column is made known to the designer and to the one constructing the towers, no, mas madali ilagay sa tower, i-base plate na lang using post tension or post installed bolts, no. Meron namang iba na aside dun sa bini-base plate na siya aside sa dinidirektang ilagay yung tower sa the existing concrete columns, no? Meron namang yung iba ginagawa nila. They're going to place a frame, no? Parang, for example, two-legged. Meron kang two-legged na pole, no? So, gagawa sila ng frame. Usually, it's made up of wide flange, no? So, this wide flange is supported to columns, no? So, depende usually talaga sa design. So, kung nagre-require pa or hindi ganun madaling ma-locate, no? Um, it uses an additional frame for some reason, for certain reasons, no? Pero kadalasan, gumagamit sila na aside dun sa tower na tinatayo mo, you also have frame. Minsan, it made up of three wide flange beams, no? Tapos naka-bolts lang siya dun sa nearest existing member. Like for example, the existing concrete columns or existing members. So depende sa design or for certain reasons, no? Ginagamitan ng ganong klase ng framing. Okay? Do you have any questions so far? Naintindihan yung lesson for today? Hello? Kaya pa? Hello?